G'day and welcome back to my workshop. Today I'm going to take you through all the upgrades I did to my Ender 3, so stick around. So the first upgrade I made, even before printing out any parts of the printer, is I added a second lead screw. I found that getting consistent first layers was pretty tricky, but it could be done. But the issue was, once you started printing, this axis would move up and this one would stick a bit due to it not being actively moved. Adding the second lead screw sorted out this issue, and I started getting consistent first layers. The second upgrade I made, and this is something probably most people print out for their printer, is just a simple spool holder. This one rides on 3 bearings and it has an insert part so that it can be printed separately. Avoiding most of the support, it still had a bit of support material. Simply has a nut in the back. We quickly check if I can unscrew it here. So it screws in quite tightly. And the nut is held captive by the extrusion here. And it simply screws in here. It took me about 3 tries to get the threads to line up perfectly. And now it locks in place firmly. Add the 3 bearings. Now you no longer have pieces of filament or pieces of plastic being shaved off from this filament roll and landing on your print. That was my biggest issue, not the actual spool holder hooking on the filament holder that came stock with the printer. The next upgrade I did was I added a PEI spring steel sheet. Comes with a smooth side, and on the other side it has a powder coated side that's textured, but I usually just use the smooth side. It's more than adequate for the prints, and once the prints cool down they self-release from the bed, so no more issues. The normal bed that came with the printer was fine, but I gouged it with a putty knife trying to remove one of my first prints that I did, and now it has a little hole through the bed. So I was kind of forced to upgrade my print bed. And then finally I bit the bullet and I installed Klipper. Now I contemplated this for about a month before doing it, because I was scared that I would mess something up and I couldn't use my printer anymore. But I finally knuckled down and installed Klipper on a Raspberry Pi and tested it, and after it worked, luckily I printed out this box. Everything fits nicely in here. The Raspberry Pi is down here. Next to it, it has a power supply that feeds the Raspberry Pi. I'll open it up now and show you how it looks inside. And this cable is just a normal USB cable that I modified. I took out the 5-volt line that leads to the printer, because sometimes when you switch it off, there's still power running from the Raspberry Pi to the printer, and then it pulls power through the Raspberry Pi for the motherboard. But if you remove the 5-volt line, don't remove the ground, just the 5-volt line, then that issue is solved. And also this cable was 3 meters long, so having a shorter cable is just a bit better for me. And here you can see what it looks like inside. I've just got the 24-volt coming in here up to the step down converter, and 5 volts running out coming down here, and I've also got on the same 24-volt powering a 24-volt fan, keeping the step down converter cool. And from this 5-volt I will also be powering some extra accessories that I plan to add down the line. This is just a little board. I'm not using the LCD currently, but this fan powers up once the Raspberry Pi powers up. It's got a heatsink and everything on there to keep the Raspberry Pi nice and cool. And finally we get to what everyone's been asking me about. This is the Micro Swiss NG Revo hot end extruder combo. It's a direct drive extruder with the Micro Swiss Revo hot ends. The hot end is a all metal hot end with the hot end going into the body of the extruder. So the throat is all metal, but the hot end is about this long, meaning the throat of the hot end extends all the way up So you don't have a space between where the you don't have a piece of PTFE tube going down between where your extruder gears end and where your hot end sits. This does increase the cost of your hot ends, believe me, especially here in South Africa, but it's worth every penny. I haven't had a single clog, nothing since I switched to this extruder. I can push more filament much faster. So with my previous setup, the fastest I could print was 90 millimeters per minute. I've now been able to print consistently at 150 millimeters per minute without any issues, no under extrusion, nothing, since just changing over to the setup. And my filament is much more consistent when I'm extruding. Also, this extruder is capable of pushing much more filament than the hot end can handle. So I do have the option in the future of purchasing a high flow hot end from E3D Revo if I so choose to get even more flow. But I don't think I will do that right now. I'd rather go for one of the obsidian hot ends and start printing with abrasive filaments before I go for even more flow. I think 150 millimeters is more than enough speed for this printer at this stage. If I don't upgrade something to get rid of the resonance on the bed, I don't think I'm going to get more than 150 millimeters out of this printer. I did need to print out a couple of more parts. This is one of the parts that Micro Swiss recommends. You'll see here's a gap that isn't standard on the Ender 3 Neo. This is because of this part. Also back here, I'll give you a shot now. This part is one that I modified. They do give you a mount here that you can print out for the CR Touch, but I had to extend it back here in order to trigger this end stop because it wasn't thick enough and the extruder would climb off here. And there you can see a close-up shot of the part that I modified and made thicker in order to trigger the end stop correctly. And the final two upgrades I made to the printer. I took some of the packing foam that came with the printer and I added it as insulation under the heater bed. The only benefit to this is the heat up times of the bed is reduced. It's not by a lot, it's about 10 to 15% faster. But if you're printing a lot of parts and you're letting it cool down in order for it to release, this does make a difference. It does reduce the power draw of the printer, but not by a significant amount. In a span of a year, you will see a difference, but it's not a lot. And the final change I made was I added these mounts down here. I did make a video about that. If you want to go and have a look, I'll add a link. This does reduce vibrations a lot on the printer, and ever since I added these, I haven't had to adjust the level of my bed. All I do is I run a bed probe every time I move the printer, but I haven't had to adjust the nuts at all. I'll add a shot right now of how I did the corner in the back, since one or two people had a question about that. And there you can see how it's tightened in the back. The wing nut just rests on top of the strain relief and it's tightened from below. How you set it is you tighten this corner first and you use this as your reference to tighten the other three corners. And that's it for all the upgrades I did in my printer. Let me know down in the comments if you have any questions and what upgrades you did to your printer and what you would like to see me do in the future. Thanks for watching.